Okay, so let's review yesterday's a little bit. If I have like, let's say, let me get this thing. Okay.
Ladies and gentlemen, we got
Alright, here we go. We did it. Alright. Yeah, that's what I thought last time. So, let's say x to the fifth, and then let's go over that. How do we simplify that? Okay, if there's no number right here, what number is right here? What's the root?
2.
2. So, for the 8, we split it up, and if there's 2 of something, that's going to go on the outside, right? So it's 2 square root of 2. What about for the x's?
You can take x squared out and you
Okay. What's 5 divided by 2? 2 with the remainder of 1. Okay, so that's what we did yesterday. Today we're doing something called rational exponents. Do you guys know what a rational is?
Fraction.
Fraction. So instead of writing like that this would be radical form. This symbol right here is called a radical. Anyways, so this would be 3 to the 4th, and then the cube root of that would be like 3 to the 4/3. Alright, see how I did that? 3 to the 4th, and the cube root, so it's 3 to the 4/3. So let's say I had 5 to the 4th, and that would be a square root, right? So what would that be in fraction form? In rational form?
5, 4 over 2.
5 to the 4 halves, which is 5 squared, right? And remember, yesterday we were doing like 4 divided by 2, right? So which is 5 squared? 7. Yeah. All right. Anyways, that's kind of that's the main gist of it. Gets a little bit messier. I guess we're gonna go the other way with it too. So, what if I said 2 to the 2/3? How would I write that in radical form? Or maybe I would put x to the 2/3.
Okay. So it'd be square root of x to the 3rd.
No.
No, it'd actually be x squared.
Yeah, it's like x squared
And
and the cube root of that. Got it? Ready? Ready, Eddie? Number 1?
so you can't just plug it in your calculator.
30. Okay, so on number 1 it says 121 to the 1/2. Your calculator can do that, but what does that mean exactly?
1, 2, 1, 1, 1.
If it's to the 1/2, what does that mean?
Means the root.
The exponent was 1.
The exponent's 1, and what else?
Oh, it's another square root.
It's a square root. So basically it's just, if it's to the 1/2, it's just the square root of 121. What's the square root of 121?
11.
11. Your calculators can do rational exponents. They can do it. Okay, well, I said that, and then number 3 probably won't be able to. So what's number 2? Number 3, how about that one? So it's to the 1/2 again, so it's still the square root. What's the square root of negative 25? nothing times itself, that's real anyway, equals negative 25, right? So, anyway, square root of negative. Yesterday we didn't have any i's, today obviously we do. Okay. So, there's two ways you could do it without a calculator. Everybody watch for a second. You could do 49 cubed and take the square root of that, which would be hard. Or you can do 49 the square root and then whatever that is, cube it. Okay, so 49, remember this is like your root. This is your number out here. So what's the square root of 49? 7. So basically this is 7 cubed, which is 7 times 7 is 49, times 7 is like 343. Okay, number 7. Negative 125 to the 2/3. Okay, what's this 3 mean?
Means is it a,
That's the
cube
square
The
root.
cube root.
Cube root.
What's the cube root of negative 125?
it doesn't have one.
No, it does.
Oh,
We did it yesterday, I thought you guys might remember, huh? Negative 5, right? Because negative 5 times negative 5 times negative 5 would be a negative 125. So this is negative 5 squared, which is
Negative 25.
no,
Well, 25.
25. Negative 5 times negative 5 is 25. Okay, number 9, we're switching convert each radical to exponential form. Like the rational exponents. Assume variables represent positive real numbers. That's so we don't have to do the absolute value thing. So, 8. What they want us to do is break the 8 down. 8 is, okay. 8 is what?
Just
So
two.
Okay, well, 2 times 2 times 2 times 2. So it's 2,
square root of 2.
I said too many. 2 to the 3rd, right? And then if you take the square root of that, what's that look like in fraction form?
3 over 2
Yeah, just over 2. So that'd be like 2 to the 3 halves.
on number 8.
That's 9.
On the
Didn't really get that, but.
8 is the same thing as 2 to the 3rd. So number 9 is 2 to the 3 halves because it's the square root.
Okay.
So they want us to break the numbers down, basically. Alright, number 11. 7 doesn't break down, right? So it makes it easier, actually. Change the page. So it's 7 to the what on number 11?
Or, first, second.
Okay, it's 7 to the first, but it's the 5th root of that, so what would that look like?
1 over
7 to the 1/5. And then keep going. X to the what?
X to the 4th.
4/5. Yeah. See how easy that is? Just put 4 and 5. Y to the what?
5.
1/5. If they don't have an exponent, exponent's 1. 1/5. Z to the
Yes.
2/5.
Okay. I'm getting there.
Starting to feel comfy.
I'm getting there.
Okay, 25 can simplify a little bit. On number 13, what does 25 break down to?
5.
5 squared, right?
Yeah.
So it's 5 squared over what? 2 over 2, which is just 2 over 2 to 1. So what's 5 to the 1 though? 5. So it's kind of obvious if you think about it. We're just doing the square root of 25 if you look at the problem. So yeah, if you change it to exponential form, it's just 5 also. So anyway, r to the what?
Second.
To the 4 over 2, and 4 over 2 reduces to 2. So r squared. S to the
3 over
3 over 2. So actually, if you get comfy with this, the easier way to write stuff. And to put, it's easier to put stuff together too. Number 15. Does 26 break down? A little bit. What goes into 26? 2 and 13. So those are prime, so it doesn't do anything else. We're just going to do this separately. I don't know if that's really helpful, but we're going to follow the book's lead on this one. So it's 2 to the what on number 15?
2 to the
To the 1/2 because it's the square root. And it's also same thing as the 13. It's 13 to the 1/2. Okay, then the letters. C to the what?
C to the 3 over 2.
3/2. And D to the
1. Not just D.
2 over 2. So it's just 1. So it's just D. Alright. 17. 125. We've seen that before. 125 is what to the what?
It's
Not 25 squared. It's
5 squared.
5 cubed.
Oh.
So on number 17, it's 5 to the what?
Or, you know,
5 to the 32.
5 to the
3 over 2.
3x.
Okay.
A to the what?
A to the 3 over 2.
3x. And B to the
B.
to the 1. So it's just B
E to the B.
to the 1. Alright, so 19. Here we go. Convert each exponent, so we're going the other way. Convert each exponential expression to radical form. Assume variables represent positive real numbers. Alright, here's the thing. Since we're putting it under the radical, you can only have one root over here. So we need to change the bottom number, because those are the roots, so that they are the same. Oops. Write that bigger. Smartboard is working, yay.
Yeah.
Probably just jinxed it. Alright, so that we can have the same root right here, we need to change these fractions to the same. So the denominators to be the same. How do I change 5 into 10?
Multiply by 2.
Times 2. And if you multiply the bottom times 2, you multiply the top times 2. So it's 5 to the 2 tenths and x to the 3 tenths. Okay, so what's our root going to be?
10.
10. Okay,
So it'd be
what's going to go on the inside?
5 squared.
5 squared. Now, okay, so we're not doing exponential form anymore, so I'm going to go ahead and change 5 squared to 25.
Okay. What do you
And
mean?
x cubed.
And then x cubed.
We might need some help on that later, but I'm not.
We just did one. Okay, on 21, the denominators and the exponents are 4 and 2. what do 4 and 2 both go into? 4. So what do I need to do to the 3 halves?
Now multiply by 2.
Right. If I multiply that one by 2, it turns into 6/4, right? So we got 3 to the 3/4 and C to the 6/4. Now they both have the same root. So my root is going to be the 4th root. What's going to go on the inside?
3 cubed.
3 cubed, what's that simplified? 3
it's,
times 3 is 9, times 3 is...
20.
And C to the 6, which doesn't simplify, obviously, so here we go.
And it just stays like that?
I'm getting there. I'm like almost there. I saw it 86%.
Oh, no, they did simplify the C's, darn it. Should have guessed that.
How do you simplify this?
Well, like yesterday. We can simplify this a little bit. What's 6 divided by 4? 1 with the remainder of 2. So it's 1, remainder of 2.
Break out here, 4th root.
Hmm.
You do the 4 on
Oh, yeah, thank you. 4 right there. Alright, 23. What do 4, 2, and 4 all go into? 4. So the 1/2 in the middle is going to change to what?
Oh, it's going to change to 2
2/4. Multiply it by 2, just like we did last time. So it's A to the 2/4 and B to the 3/4. So the root is 4. And we got 3 to the 1,
It's just 3.
which is 3. A squared and B cubed.
You can't get anything.
Right, that one doesn't simplify, because if your power has to be bigger than the root for it to simplify. Like 6 was bigger than 4, so we could kind of divide it out. Alright, 25.
I think we should just call it 24.
Yep.
No, like not even do 24. Just
Not
like-
even. Challenge without a calculator challenge.
What? No?
Do you guys know what 0.4 is without what 0.4 is like as a fraction?
No. Would it be? It's not a third, is it?
Well, it's 4/10, that's what 0.4 means. But what's that reduced to? 2/5. So that's 1 2/5. What's that as an improper? 7/5. So basically what we're doing on 25 is figuring out what 32 to the 7/5 is.
Can I use my calculator?
Nope, it said don't use a calculator.
Dang it.
Okay, guess what the 5th root of 32 is?
I don't know. Probably 2.
2. So 5th root of 32 is 2. 2 to the 7th. Okay, 2 to the 7th. Well, this is 2 to the 5th right here. So to do 2 to the 7th, we multiply that by 2 by 2.
Okay.
So 32 times 2 is 64. 64 times 2 is...
128. Look at that.
So much fun.
It's not.
Not really.
Sorry, but like, I hate to crush the things you put out, but this is not fun. This is no. No, we're not supposed to do 27.
27.
No, you
What
said
are we
26.
going to?
30. Did I write it down? No,
No,
I
you wrote it
didn't.
down.
I did not write it down. That was yesterday's.
What?
Um,
No.
27. What's 0.6 as a fraction? 6/10, which reduces to
3/5.
3/5. Okay, what's the fifth root of 100,000?
Well, you can divide that by 2.
No. Okay, what multiplied to itself 5 times equals 100,000?
Probably 100.
1,000.
What's 1,000
Is
times?
it 10?
What's 1,000 times 1,000?
1,000 times 1,000.
A million.
Is a million.
Okay, it's 1 with 6 zeros. Okay, what do you multiply 5 times to get something with 5 zeros?
10.
10.
Yeah.
So the fifth root of 100,000 is 10. 10 cubed is 10 times 10 times 10.
Well, 10 times 10 is 100, and 100 times 10.
That one.
Woo! I'm on a roll.
I don't know why I circled that one. I have a feeling we're gonna have some people cheating on these. All right, 27.
We just did 27.
29 says 27. Negative
Oh.
4/3. Okay.
Well,
What was a negative exponent? We haven't talked about that today. That kind of surprised me that they threw that one in there.
Yeah,
Let's-
you're right. We should just stop.
yeah.
Why did they just
No, no, no,
put
no, no,
that
no,
in
no.
there?
No,
Okay.
that's a good idea.
What's 3 squared?
3 squared
Nine.
is 9.
Nine.
and
What's 3 to the
is
negative 2?
Negative 9.
No,
It's 9.
no.
It's
Well,
It's not
3 times negative.
Oh, you're good.
Oh,
okay. This is
No.
1/9.
I
Okay.
hate this.
It's a reciprocal. Reciprocal. That's all it does. So kind of ignore it at the beginning and then we can do reciprocal at the end. So on 29, what is the cubed root of 27? What times what times what? We did this once today.
oh, that's
3.
right. Because we have a big fraction. You have a negative. Just to put it on the opposite side.
Yeah, negative on the exponent flips it. So the cubed root of 27 is 3. So what's 3 to the 4th? Well, 3 to the 3rd is 27. So 3 to the 4th will be 27 times 3. Which is 81. But that's not my answer. What's my answer? 1 over 81.
I see.
You know what I saw this morning, Mr. Jordan?
What?
I saw that commercial you were talking about.
So did I.
Oh,
I'm
what?
sorry.
You did too?
Oh.
The eight, Captain Ahab and the
Yeah.
party.
Yeah, I got it on the spot.
Pretty good, wasn't it?
Okay. Can you
I
explain
bet
that
that's a
to
Super
Jordan?
Bowl commercial.
I was just walking, and then on the TV, I see a guy sticking out of a car, and I just am like, hold up.
Wait a minute.
Wait a minute.
Hold on. Wait a minute.
Steady, steady. What is he? He does some curse when they.
Oh, I don't remember. But there was a guy there, and he was like unlocking his car.
Yeah.
Yeah.
They're like following him and because they think he's gonna pull out and then
Yeah.
he just locks his car. And he's like, "Oh, Dad, blast it." Or something like that. I don't remember what he said. All right, we got all that recorded. That's good.